So next up is Mike Daniels. He's in the Earth Observing Lab, and he's going to tell us about the CHORDS platform.
Hi, everybody. Yeah, I'm going to talk about this CHORDS project, which stands for Cloud Hosted Real-Time Data Services for the Geosciences. I'm the PI, but I get to represent all the great work of this team before you, and it's sponsored by the EarthCube program. So take a look around you. There are real-time sensors all over this room. Some of them are traditional sensors that are monitoring temperature to know when to turn the heat on. Others are in your hand. There are real-time sensors in these devices. And of course, real-time data is very important for the geosciences. It's important in terms of measuring hazardous conditions and floods rising and that sort of thing. But also when we do field experiments, we're seeing a dynamic phenomenon that we have to position assets around, and we use real-time data for that purpose as well. It's also a very prominent part of the geostrategic plan. They mention sensor web networks and making those data transparent and available, so it's getting attention at that level. In the Earth Observing Lab, we have a real-time display that we use that has video from the aircraft. It has the radar data, the positions of multiple aircraft. But the issue with that display is it's just like a closed-circuit TV. The data aren't accessible, so you can't put them into your algorithms. You can only view them, but that's very valuable. Then we have small research teams who are also taking measurements, but they're focused on the measurements, and their data generally aren't accessible on the internet. For example, last year we heard about Paul Casera's 3D printed weather stations that are being deployed in Africa, for example. So all of this comes in the context of this Internet of Things, and you can research that topic. But it basically says so many more things are going to have internet connections, your TVs, your stereos, maybe your home weather station. And it might turn out that those things could be used in a geosciences context in a way that we didn't think about. For example, your phones have accelerometers in them to play games, but those same accelerometers, if crowdsourced, can be used to detect and predict earthquakes, and then eventually notify the people with the cell phones of where those earthquakes are going to occur. And so if you put all this data together, it's really a big data problem. Imagine if you could draw a box around a geographical area and see all the real-time sensors that are there, and what's being measured, what's the spatial and temporal coverage of those measurements. You have to implement data standards for that. And of course, most of the scientists I work with, that's the last thing they want to do, is spend their evenings looking at data standards and researching those. And so really, that's where the cyber infrastructure folks come in. And so in 2013, we had a workshop here in EOL. We invited 76 participants from across the geosciences. That'd be polar, the hydrology, oceanography, earth sciences, and atmosphere. And we came up with some infrastructure that we think could apply to all of those fields. We called that Project CHORDS. We gave you a couple of examples of real-time multidisciplinary research, such as studying the Great Lakes Basin. You need to measure the inflow, the outflow, the evaporative fluxes, the surface temperature of the water. And then another case, we heard about Vortex 2. Well, it turns out that around that time, there was an infrasound network from the seismic community that was positioned right in that area. What could have happened if we would have had access to that data? Could we have done a better job of predicting where the hazardous weather was? So we developed this CHORDS portal, which is very simple. You get an Amazon Web Services account. It's free for the first year. You configure your portal with the measurements that you're taking, and then you start sending data to those to this portal. The way that those data are interfaced with CHORDS is just a URL. So if you were to type this URL into your browser and press enter, one point would be entered into your portal. So it's very, very simple. You can see the variables there and how those get entered. So that's easy to script up. Getting the data is the same way. You do it with HTTP. So once you've done that, you have your CHORDS portal. You can monitor it from a remote location. You can also download spreadsheets, which are pretty common for researchers to need. But you also get some of the standards that are emerging, like SensorML for describing your sensor and GIS mapping. In 2016, we got funded for another 3 years. We have a really diverse group of people in both science areas and across the nation. And so we're expanding CHORDS to go into more areas, in particular more portals beyond what we already have, which you can see at the bottom. And then looking at this services part, what do we do with that data once we've acquired it? So the first step is to get the data, the second step is to process it, and then link those data to existing archives. So I've been wanting to do standards for a number of years, and it couldn't come too soon, as I'm starting to show my age and getting recruited for all kinds of things like being Santa, which I'm going to be this year. And so while I'm putting these kinds of things on my Facebook page, our early career researchers are talking about sharing data for the public good. They're very passionate about this. They want to give the data into the hands of the local peoples. It's just been really exciting to work with a team like that. So to me, that's really the beauty of EarthCube and CHORDS. It takes the experienced cyber infrastructure people who have the knowledge of the standards and pairs them with early career folks who are wanting to make a name for themselves and get their data more exposed. So thanks.